Welcome back. This is part 2 of chapter number 5, and in this part we are going to discuss about some more questions and mainly about programming. Okay, so now we'll go to question number 4. How are the statements in high level programming language is converted into machine language, that is binary language? So how do you understand this question is, for example, you have int, you have something called int a is equal to 5, and we have something, this statement int b as 10. Okay, so this is a high level language program. How this is converted into low level language? So for this we use something called another program called compiler. Okay, through this compiler we are able to translate this high level language into a low level language. So in between we use a compiler, a translator. Okay, so usually now in modern days now we use compiler. Before that we used to have interpreter. Okay, so both has the same function, but there's a basically one basic difference. Compiler translate as a whole, interpreter translate line by line. Okay, so that is the main difference. So question number 5 says that why learn assembly language? So if you go for higher studies for masters, you will be having a subject called compiler design. Okay, so so we have to understand how the compilers work for high level language. For that we have to be expert with machine language. So that's why we need to learn assembly level language. Okay, um, now we'll come to the most important part. Explain how the following program written in high level language is converted into assembly level language and into machine language. Okay, so we do have three different programs. One is addition, another one is subtraction, and the third one is multiplication. So in this part I will be discussing with you how a simple addition program is converted into assembly level language, and from assembly level language how it is been converted into machine level language. That is what we are going to see in this part. Okay, so we will start with 6a, add two decimal numbers. So for any high level programming language we have pseudo program. What is the meaning of pseudo program? Pseudo program means it's a short way of writing code. Okay, so it's basically an algorithm. It can be algorithm also. Okay, short way of writing the code or an algorithm. Okay, so when we add two numbers we need a variable, two variables. So I declare the variable as integer a is equal to 5 and int b is equal to 2, and we say that a is equal to a plus b. So what is the meaning? So we, in a there's a variable called a which will store 5, and then we have a variable called b, so which will store 2. Okay, then we have the mathematical expression a is equal to a plus b. So this a will be having 5 and b will be having 2. So 5 plus 2 is equal to 7, so a becomes 7. So display the result. So a will have the variable 7 now. Okay, so when this program is executed, a will hold the number called 7. Okay, so this is basically a short way of writing the code. So when you want to display the result, okay, in Java, so you have a different syntax. Okay, so if you want to display in C or C++, you can say that C out. Okay, or in some other language you have something called printf. So there are many ways to display the result in different languages. So we don't care about those things. So this is what we say a short way of writing the program. So if you understand this logic, this concept or logic can be converted into any other high level programming language like Java, C++, or Python. Okay, so now what I told you that This high level language will not be understood by the computers. So we have to make them understand. So the first level of translation will be in terms of mnemonics. Okay. So here we say move immediate a comma 05 MVI. MVI means move immediate. Okay, so they have taken the letter M and then V and then I, so it is called MVI. Okay, this is equivalent to, in high level language, int a is equal to 5. So what is the meaning here? So in the previous lessons, you know that we have studied about registers. Okay, so inside the CPU we have many registers, and let us say that we have a register called A. Okay, so when this instruction in high level language, when this instruction in high level language is executed, it is being translated in assembly level language as move immediate A comma 05. That means in the A register store the data 5. Okay, then when we have int b is equal to 2. So in high level language, in assembly level language, it is declared as move immediate the data to in B register. Okay, so there is the meaning here. And finally, we have A is equal to A plus B. So what is the meaning? Add the data of B. Add the data of B. B is having 2. This data is added with the data of A. A is having 5. Okay, so 5 plus 2 becomes 7 here. Okay, so this 7 is being stored in A register. Okay, and out display, that means display the result. Display the result. So whatever is available in the A register, display this as an answer. Okay, so this is the meaning of assembly level language. And let me tell you, this is everything, it is in still in alphabets. Okay, so still this instruction is in alphabets computers does not understand, so we have to convert these alphabets into, again, into a number which it is easy for the computer to translate. So we use something called as opcode or operational code. Okay, we use something as opcode or operational code. What is the meaning here is this instruction move immediate a comma 05. So this will not be understood by the computer. So we have to translate that move immediate a is equal to 3e. That means what I'm trying to say that is there is a table. Okay, where the instructions move immediate, okay, add, subtract, okay, out, so all these things, they have to be translated into some other language which the computer understand. So the language which the computer understand is numbers. Okay, so this is in hexadecimal. Move immediate a, so this becomes 3e. So we have move immediate b, so this becomes 06. So this is a table where they used to see the table and then translate. Okay, so now move immediate a comma 05 means 3e. 3e, once this instruction is been decoded by the computer, it will understand that move immediate a. Okay, so what is move immediate a? That means we are trying to declare a variable called int a. So where is the data? So what kind of data we have to store in the variable a? So it is 05. Okay, that's why we give 05 here. So similarly, we when the computer sees that 06, so 06 has been translated as in assembly language move immediate b. So when we say move immediate b, the computer understands that okay, it is an instruction in high level language where int b is equal to, where is the data is 02. Okay, so this 02 is been translated in this way. So this is how it is been translated, and add b is being given as this code as 80 and out is given as d3, but still this is in hexadecimal code. Still it is in hexadecimal code. Computer does not understand hexadecimal. Again this has to be converted into binary numbers. Again this has to be converted into binary numbers. So how do we do that? So okay, how do we do that? Okay, you know that the decimal number 7, okay, 7 is being converted into binary as 0 1 1 1. Okay, so this is a binary number. This 0 1 1 is being converted as 7 in hexadecimal. Okay, so the decimal number, say say it is 10. Okay, the decimal number 10 is converted in binary number as 1010. Okay, so again this is been converted as 0, okay, it is converted as a 16. Similarly for e means it is number 14. Okay, 14 is converted in binary as 1100 base 2. Okay, so in hexadecimal it is nothing but e. Okay, in hexadecimal e. So you can review this concept in chapter number 2 where we discuss about binary data numbers. Okay, number representation. Okay, so when we have the opcode 3, so we have the opcode 3, so this is been converted as 001, I mean 00, sorry, this has been converted as 0011 and e is been converted as 1100. So this is how the computer understand the instruction move immediate A. Okay, so this is the instruction for 3E, comma 05. So when we say 05, again this will be converted into again binary numbers. 05 is converted as 05 is converted as 0000 and 5 is converted as 0101. Okay, so totally there will be 16 bits. Okay, totally there will be 16 bits, but each bits is represented as 1 byte. This is 1 byte. Okay, so now let us see here. This 3e is converted as 0011. So 3e is converted as 0011. So that's why I've written here 3e 0011, e is 1100, and the data is stored as 000 and 0101. Okay, so this is for int a is equal to 5. This has been translated as in this way. So it's a long way. It's a long discussion. So similarly int b, and this is add b, and then this is the out display. So out display. So what is this? This is the answer. Okay. So 05 plus 02. Okay. So 000 0101. So 000, this is 0010. So when you add, it will be 0000111. So when you add, so this is okay 07. It has been translated as this binary number. So this is the answer. So in the output device, 7 will be displayed as the answer. So this is the simple example of using um, binary addition here. Okay, so this is the example of using binary addition. Now next we do have, okay, so let me stop here. So as I told you, so this add or addition of two decimal numbers is over. So subtraction of two decimal numbers, the logic is the same logic, but the only difference is we have to subtract the two numbers. Let us go through the first step number one. Step number one, write this pseudo program to subtract two decimal numbers. So for that, everything is the same, but here we just change the sign, okay, a minus b, and display the results. Everything is the same as before, and we have to write the assembly level language. It is move immediate a comma 05, move immediate b comma 02, and then we have to use sub b, okay, and display the result, okay. And here, so everything has been translated into binary numbers. Please note that for sub b the code is 90, so because of that we have to convert this 90 in binary numbers. Previously it was 80 for addition, okay. So this is how we convert this, okay. So now multiplying two decimal numbers, I just leave this as a homework exercise for the students to write in machine language, okay. So this is the logic, okay. This is the program in in high level language, and here this is how we write in assembly level language. So I'll just give you as a homework. Now we come now, part 3 discusses about this question. We'll meet you in the next video. Okay, thank you.